Saturn 1-1B Quarterly Film Report number 23 covers progress during the period January, February, March 1965. Highlighting this report period was the successful launch and flight of the 8th Saturn SA-9 and the equally successful orbiting of the first Pegasus meteoroid technology satellite. In early January, Pegasus underwent systems tests at Cape Kennedy. Tests included unfolding and folding the 96-foot wings. Following testing, the satellite was placed inside the Apollo boilerplate module, and both items were then moved to the launch pad and erected atop the vehicle. The major objective of SA-9 was inserting the Pegasus meteoroid technology satellite into Earth orbit. Other objectives included testing a completely closed-loop guidance system for the second time and an iterative guidance mode for the first time. Pre-launch checkout progressed satisfactorily, culminating with a successful countdown demonstration test on February 12th. Vehicle countdown activities began 3 days later. Liftoff occurred on February 16th at 9:37 a.m. Eastern Standard Time. The SA-9 launch marked the 8th successful flight of the Marshall-built boosters and the 4th straight successful flight of the Douglas S-4 stages. The SA-9 booster was the last to be built at Marshall. The 2 remaining Saturn I boosters were built by Chrysler at Marshall's Michoud operations. The first stage burned for 145 seconds, and separation occurred satisfactorily. The S-4 stage burned about 474 seconds, at which time the programmed cutoff velocity was obtained. S-4 stage flight was satisfactory. The first flight of an operational unpressurized type instrument unit was also successful. The Apollo Command and Service Module was jettisoned from the second stage by spring mechanisms, leaving the Pegasus wings free to unfold as revealed by onboard TV cameras. The wings successfully deployed to the full open position. Pegasus A is presently obtaining information concerning quantity, size, and velocity of meteoroids in the near-Earth space. SA-8 and SA-10 will also launch Pegasus satellites. Work has progressed steadily on these vehicles. At Michoud, following completion of post-static checkout, S-18 was shipped to KSC by Chrysler, arriving at the Cape February 28th. It was erected on the pad March 2nd. During pre-launch checkout, 1 defective engine gas generator was discovered, and all 8 were replaced. S-48 was flown from the West Coast February 23rd and arrived at the Cape February 25th. Checkout and painting of the stage with a special paint was completed March 11th. The stage was erected atop S-18 March 17th. SIU-8 was delivered to the Cape on March 8th by Guppy. The unit was transported to Hangar AF. Checkout and alignment were completed, then the unit was painted. On March 18th, erection of the IU was completed. Meanwhile, at Marshall's Michoud operations, Chrysler completed post-static checkout of S-110 on March 5th. Preparations for shipment to KSC are in progress. At Sacto, S-410 static firing was successfully completed January 21st. This firing marked the completion of the S-4 stage static firing program. The stage is in storage at Sacto, awaiting shipment to KSC. Checkout of SIU-10, located at Marshall's Quality and Reliability Assurance Laboratory, started in January and is scheduled to end in early April. Satisfactory progress is being made by the contractor, Fairchild Hiller, on Pegasus B and C, which will be used for SA-8 and SA-10 flights. Final assembly and checkout on Pegasus B has begun at Hagerstown. After vibration testing at General Electric, Valley Forge, Pennsylvania, which is scheduled for early April, the unit will be flown to the Cape. Pegasus C structural fabrication is complete. Black boxes for the satellite were still being assembled at the end of March. The Pegasus prototype is being held at Fairchild Hiller's Hagerstown facility as a test bed for Pegasus B and C modifications. Possible deletion of prototype environmental tests at General Electric is under study. The Saturn 1B dynamic test stages were received at Marshall January 4th, arriving on the same barge tow. Following receiving inspection of the Chrysler-built first stage and the Douglas-built second stage, they were erected in the stand. Assembly of the dynamic test instrument unit was completed in early February at Marshall. Following installation of simulated components, the unit was installed atop the S4B dynamic test stage. On January 19th, the helicopter transported spacecraft adapter arrived at MSFC and was subsequently installed in the stand. Testing of the SA-203 configuration began February 18th and was completed March 2nd. This configuration consisted of the first and second stages, the instrument unit, and a shroud simulator. Upon completion of the SA-203 configuration testing, a spacecraft was installed atop the test vehicle, and the SA-201 and 202 configuration testing began. Saturn 1B dynamic testing will continue through next quarter. A major Saturn 1B milestone was reached when the first 1B booster was static fired at MSFC. Chrysler completed stage pre-static checkout at Michoud on February 2nd. The stage arrived at Marshall by barge March 14th. Following installation into the test stand and preparation for tests, the booster was successfully fired for 35 seconds. A long-duration firing is scheduled for April 13th. At Chrysler Michoud, S1B2 stage assembly was completed March 1st. Booster pre-static checkout began and continued throughout the quarter. Tank clustering for S13 was also completed. Other S1B3 assembly operations continued on schedule, and assembly is expected to be completed early next quarter. Fabrication operations continued for S1B4. Tank clustering is scheduled to begin early next quarter. Fabrication operations are also underway for S1B5. At Douglas's Sacramento test area, the non-flight J2 engine was removed from the battleship test stage and replaced with a flight configuration engine. The new engine has the capacity to gimbal, which is needed for the remaining tests. Engine chill-down, propellant utilization tests, and hot firings were conducted by the end of March. A full-duration firing was cut off after 29 seconds on March 19th due to a gas generator body exceeding safe value. A second full-duration firing set for March 25th was rescheduled for early next quarter. At Huntington Beach, Douglas's structural test program involving various S4B components, such as this static test thrust structure, was well underway. Other items undergoing qualification testing were the liquid oxygen tank assembly and an S4B forward skirt, which was tested to failure to determine maximum load conditions. Also at SACTO, Douglas completed installation of ground support equipment and instrumentation required for facilities checkout stage tests on beta test stand number 3. Facilities checkout tests were started in mid-March, with propellant loading tests to be performed early next quarter. Checkout of the first flight second stage, S4B-1B1, was stopped March 30th. LH2 tanks modifications and installation of late parts are scheduled prior to shipment to SACTO in April. Checkout will be resumed and completed at SACTO after final parts installation. Work on S4B-1B2 included welding segments of the forward and aft common dome and joining the propellant tanks and skirts. Systems checkout for this stage is scheduled for next quarter. Tank insulation of S4B, 1B3, and 1B4 was completed. Installation of electrical and mechanical systems on these stages is underway. At Rocketdyne's Santa Susana facility, 200K engine qualification testing started March 1st is progressing satisfactorily. The first engine has completed 11 calibration tests for 1,560 seconds and is currently undergoing safety limits and malfunction testing. 7 calibration tests have been completed on the second engine for 1,085 seconds. All tests are scheduled for completion in early May. Following successful completion of Rocketdyne's J2 engine preliminary flight rating tests last quarter, the test engine was removed from the stand. It was completely disassembled, then inspected at the Canoga Park facility to determine the extent of engine wear after repeated firings. At Santa Susana, acceptance testing of the first J-2 flight configuration engine was conducted January 22nd. The following day, the engine was delivered to Douglas for use in its S-4B battleship test program. At Santa Susana, major modifications on vertical test stand number 3 are now complete. The stand, reactivated in January, will provide improved propellant conditioning and increased overall utility. At MSFC, beneficial occupancy of the J-2 engine test facility came about in January. The propellant tanks for the test facility have been installed in the stand, with testing scheduled for next quarter. Meanwhile, at Wiley Laboratories, Huntsville, instrument unit vibration testing got underway in February. Testing will determine the ability of the IU structure to withstand anticipated flight environment. Assembly of the structural test instrument unit was finished. A breadboard version of the IU's launch vehicle digital computer has been delivered to Marshall by the manufacturer International Business Machines, Owego, New York. The unit, used in guidance operations, is now being checked out and evaluated. The first prototype computer will be delivered next quarter. At IBM's Huntsville facility, a structural assembly fixture, a major piece of hard tooling for use in the instrument unit assembly, was received and installed. Assembly of structural segments manufactured by General Dynamics, Fort Worth, Texas, for the first flight instrument unit was completed March 23rd. Component assembly started March 24th and will continue into the next quarter. At IBM Space Guidance Center, Owego, radiographic inspection was accomplished on the first piece of production hardware. The unit, a magnesium casting, forms the base assembly for SIU-201's Emergency Detector System distributor. Machining operations were also performed on a component of the guidance and control system for use in the launch vehicle data adapter. Meanwhile, at MSFC, installation of computer equipment for the Saturn 1B development breadboard continued. Some Saturn 1B testing with this unit has already been accomplished, with additional tests scheduled. In summary, accomplishments during January, February, and March strengthened the overall enviable record of the Saturn I and 1B programs, the near-perfect flight of SA-9, preparations for the operational flight of SA-8, Saturn 1B dynamic testing, major buildup of ground support equipment, and the short-duration firing of the first Marshall-engineered Saturn 1B booster.